system. In education system, the biggest problem is one human being coming and telling another human being, how many times I should tell you? Still you have not understood that. That's the worst thing in an education system.
Okay, this is circular basically. That is this. Okay, and say this is D2. Okay, a tapered circular section where one end, that is the higher end, I have named as D1, and the lower end I have named it D2. Now to find the tapered section, that is the change in length in the tapered section, what I'll do is I will take a section. I'll take a section dx at a distance of x, where this total length is L. L is the total length of a tapered section. To find the tapered section, to find the change in length, what I'm doing is I'm actually taking a small section dx. It's looking a bit messy. I'll make it clear. Okay, say this is dx, the thickness of this is dx, and say here at whatever point we are taking this thickness, say this have a dia d, because nowhere d is common. Since the section is getting tapered, it is getting decreased along the length, so obviously nowhere the d is common. So at some thickness dx, I am assuming that let the dia is d at a distance x. So now let us understand what is d. What will be d then here? D will be d1 minus d2 along the section L at a distance of x. Okay, why that? Because I'll explain you that as well. So if you see, this is the dia, this is our concern, right? We don't want this. This is what? This both are d1. So we want this. So from this full, we are going to take out this. So this is quite similar to this much part. So that's why d is equal to d1, that is the total, minus the change along the length at a distance of x. So this is what? D. So when we get d, now I'll find what is the change in the length in dx. So change in length in dx is nothing but, we know by formula PL by AE, where P by A is what? Stress. That is stress into length by E. So what I'll do is I'll find the value of stress. So finding the value of stress, I need to find what? A. So A will be pi by 4 into d square. Since this look complicated, I can write this one as d1. I can write this one as d1 minus k into x, where k is nothing but d1 minus d2 by L. Clear? So here, since the value of d is this, that is d1 minus kx, now I'll find the value for area, that is pi by 4 d square. So what it will be? Pi by 4 d square is d1 minus kx square, right? So when A is this, therefore stress will be what? Force by area. So what is force? So this is the force irrespective of tensile or compressive. Area is, here let us take P, since we are taking P from the beginning, so I should not disturb this. So this is P, that is load, and that is nothing but force, and area is pi by 4 d1 minus kx whole square. So what it is, this 4 goes up, that is 4p by pi d1 minus kx square. So this is what the value of stress. So we'll put it here. Change in length for dx is 4p by pi d1 minus kx square into L by E. Now this is what? This is the length, that is the change in length, that is the change in this particular dx. But we are concerned what? We are concerned for the whole tapered section, that is for length L. Therefore, we will find the total change. Therefore, the total change is nothing but 0 to L for this section dx. Kx, this will be, here L was what? This L is for section dx by E. So what are, we'll take out the constants out. So when we take the constants out, what are the constants? 4p by pi E, 0 to L, 1 by d1 minus kx square into dx. Now we can integrate the same. Now when we integrate, what we get is 4p by pi E, here it will be d1 minus kx minus 2 plus 1 minus 2 plus 1 into d by dx of, or in simple 1 by dx, in simple I can write it 1 by dx of this particular minus k. So here what we get, 4k by pi E, this is minus 2 plus 1, this is minus, and this is again minus, so this will be coming down, that is d1 minus kx into 1 by minus k. Minus minus get cancelled, so we are left with 4p by pi E k by, this is what? This is 0 to L, right? So 1 by d1 minus kx 0 to L. So when we solve further, this will be 4p by pi E, k is what? d1 minus d2 by L, correct? See from here, k value is what? d1 minus d2 by L. So I am replacing the same value. In place of k, this k, I am putting this into 1 by d1 minus kl. So in place of kl, I will put the same thing again into L minus 1 by d1. This get cancelled, even this get cancelled, so this will be what? This is 4p, this L goes up, 4pl, this L I'll take up, this is pi E d1 minus d2, and here we are left with 1 by d2, 1 by d2 by 1 by d1. So this we get 4pl pi E d1 minus d2, this is d1 minus d2 by d1 d2. So this again get cancelled, so finally we will be left with 4pl pi E d1 d2. So this is what? This is the change in length in a tapered section. Clear? So in this case, what we got? We got the change in length in the tapered section is change in length for this tapered section is 4PL by pi E D1 D2 against PL by AE. So whenever there is a tapered section, instead of using this PL by AE, one should be using this 4PL by pi E D1 D2, where D1 is nothing but the dia of the higher section and D2 is the dia of the lower section. I hope this is clear to all, right? Clear? To understand this, let me take a example. We have taken what? Tapered section as 4PL by E. So till now we have understood two things, that is change in length in a rectangular or square section is given by PL by AE, whereas change in length in tapered section is given as 4PL by E D1 D2. Okay, now using this, let me take an example. Say this is an example where force is say 10 kilonewton, and say here the loads are 20 mm, 200 mm, 100 mm. Okay, and here this height is 10 mm, whereas this height is 15 mm. So what we understand from here it is, so if you see for this taper section, if I take it separately, say this is, question is asked what is the, here E is also given, so it is 2 into 10 power 5 Newton per mm square. So in this case what we do is, see, I'll explain you individually. So this is 1, 2, 3. So body 1, load is how much? F is equal to 10 kilonewton. So for section 1, what is load? Load is 10 kilonewton, that is 10 into 10 to power 3 Newton. What is area? Area is what? 20 into 10. 20 into 10 mm square, right? Similarly, section 2. What is section 2? Section 2, if you see, it is tapered. This is D2, this is D1, or you take D1 and D2 otherwise, because anyway both are products. So I'll take it D1 as 15 mm, D2 as 10 mm. Whereas section 3, force is equal to 10 kilonewton, 10 into 10 power 3 Newton, and area is 15 into 100 mm square. Clear? Now how we find this then? Therefore the change in length here for this case, for 1, PL by AE, P will be 10 into 10 power 3, L is 20, area is 20 into 10, A is 2 into 5. We get the value for change in length in 1. Similarly, the change in length for 2 will be what? Here this is the difference, so I'll better take the other color. So here change in length for 2 is 4PL by E D1 D2. So it will be 4, P is same, 10 into 10 power 3, length is 200 by E is 2 into 10 power 5, D1 is 10, one is 10, one is 15. So you write 15 first or 10 first, doesn't matter. Okay, so this is the basic change in length 2. And similarly, length 3. Length 3 is again easy, right? Change in length 3 will be PL by AE. So P here is 10 into 10 power 3. Length is 100. A is 15 into 100. We have done here into 2 into 10 power 5. So from here, then after finding individual, therefore we can go for change in length in total, that is 1 plus 2 plus 3. Clear? So that is how we go for solving a tapered section. Whenever a question will be there for a tapered section, that is how we solve using this particular.
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for free, ANC.